Okay, so here's what we just did. The steps we just went through with our 0.99999 repeating. Equals x, multiplied both sides by 10. Subtracted, got 9 equals 9x, and that meant x equals 1.
Yep.
Okay. So we're going to try to do that with another series. And this is a clever one. That's in Ellenberg's book, but it's pretty easy to understand. We're going to look at this series. 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus dot dot dot. How do I get the terms of this series?
You multiply it by 2. To get the next term, you multiply the term before it by 2.
Do you see that?
Yep. Then you get...
What would the next term be?
That would be 64
Good job.
plus 128.
All right, awesome.
All the powers of 2.
So this is x. So I'm going to do a similar thing here. I'm going to multiply, I don't know what this sum is, but I'm going to multiply this time by 2 instead of by 10 last time. So I get 2x equals, what's the first term?
It's 2.
2. What's the next term?
4, 8. It's just like the term before it, but you knock out the 1.
Okay. So with this series, when I multiply by 2, I get something that looks a lot like the term before it.
But you knocked out the 1, so it's smaller.
It's smaller, huh?
So what number, when you multiply it by 2, gets smaller?
Yeah, well, so I have an interesting thing here. 2x is the same as this one, x, just subtracting away 1.
Well, that means x...
I just want to make sure your brother understands. 2x, which was this series, is the same as this series, just subtracting away the 1. Do you see that?
Yeah.
If I take away that 1, if I subtract that 1, I get 2 plus 4 plus 8 plus 16.
Which is that series.
Okay, now how am I going to solve this?
You subtract an x from each side. Or, yeah, you subtract an x from each side.
Okay, and I get x
equals minus 1.
minus 1.
Weird. Because you
Well,
sum it up finitely. It's bigger than minus 1. But I guess infinitely, it is minus 1.
Huh. But this is basically the same math that we used to show that the 0.9999 equals 1. So in that case, we got something that made sense, right?
Yeah, this doesn't really make sense.
In this case, do you believe this series adds up to minus 1?
No, not really.
How come?
Well, because of the same thing I talked about for the minus 1/12 series. You sum it up finitely, and you get a positive number.
Yeah.
Even just the first term is bigger than that.
What do you think? Do you think this adds up to minus 1?
No.
Okay, why not?
Well, it's the same thing what he said. If you sum all the positive numbers, you get a negative number. It doesn't really make sense.
It doesn't really make sense, does it?
No.
So that's why Ellenberg was calling our other approach, or the other approach, algebraic intimidation.
Yeah.
When you show that way about 0.9999 equal 1, you multiply by 9 or by 10, it seems to work and it seems to be convincing. But we do the same thing here and we get an answer that's a bit of a head scratcher, right?
Yeah.
Okay?
Yeah.
So we have to figure out. So mathematicians actually spend a long time trying to figure this out. Do you want to see one more that's a little kooky?
Sure. All right.
Okay. And then I'll talk about mathematicians and trying to solve this, figure out all these strange mysteries. Okay, we'll do one more. Oops.